All right, good afternoon, everyone. Hope you all
Good
had a good
afternoon.
weekend. All right, so last class we were talking about the limit, right? And we were discussing how initially when we discussed the limit, it was a very visual thing where we could talk about coming in from the left and the right. And then there's a problem where I gave you a bunch of conditions where we had to draw a graph that satisfied some criteria. And then we moved on to how do we figure out what the limit of a function is without the graph, just algebraically. And that's kind of what we started to get into last class. So I wanted to start with the problem that we ended with last time. We ended with this limit, and we were trying to figure out the limit as x approach 2 of this expression right here. So we did the work, and I can go through it again here in a second, but we got an answer of 4. And so I just want to make sure that we all understand what this means. So if I were to give you a function f of x equals, or give you the function f of x equals x squared minus 4 over x minus 2, and I asked you to evaluate the function at 2, that just means you'd replace the x's with 2 squared minus 4 over 2 minus 2. You get 0 divided by 0, which is undefined. So it is impossible to plug 2 into this function, okay? It's impossible to do it. So if we look at the graph of this function, we will have a hole at 2, right? You go into 2 and we have a hole. Now, the limit, right? The limit as x approaches 2 of the function, this we can do, because what we do is we use the properties of algebra, right? We take the expression. We already know that if we try and plug 2 in, we're going to get 0 over 0. But there is some algebra that we can do. Get our difference of squares up top. And then that allows us to cancel that factor, x minus 2. And that's where I said we had that little asterisk, right? Like the only way we can cancel that is if we promise that we'll never let x minus 2 be 0. In other words, we can only make that cancellation algebraically if you promise me you're not going to let x be 2. Okay, so as long as you promise me that, then we can cancel them. So we cancel them, and then what we do is we try and figure out what happens as x gets close to 2 in this expression x plus 2. Well, if x is really close to 2, then a number that's really close to 2 plus 2 is really, really close to 4, right? Close to 4. It's never actually necessarily going to get there, but it's getting closer and closer to 4 the closer x gets to 2. And so even though our answer here is 4, please understand we're saying that the function is getting closer to 4 as x gets close to 2, right? That's the whole like what's the word I'm looking for? Spirit. The whole spirit of the limit is that you're not actually allowing x to ever be the value that you're going to. But you are investigating what happens as you get closer and closer and closer to that value. So the graph of this, let me just bring up the graph. We did, I think, look at the graph last time. If I were to graph it, here's the graph. And we can't tell, right? You can't tell from the graph, but if you try and go to 2 and plug it in, let's see what happens. If we try and plug 2 in here, we get right there, we get undefined. So there is technically a hole there. But as we come in from the left, so imagine there's a hole here. As we come in from the left and as we come in from the right, those y values, oops, I passed it up. Those y values are getting closer and closer to 4, right? No matter which side we come in from. I know I've already stated this, but is that clear? Does anyone have any questions on that? We're good? Okay, now why am I pointing this out again for like the 5th time? Because in our formulas, okay, in our formula sheets that you can find on Canvas, I have something there for you called the limit summary, all right? And what this does, and it's gonna take us a few weeks to get through this whole page, but let me just try and explain what it's saying, all right? This is a summary of what happens or what you need to do when you're evaluating limits, all right? So this is only good when we're talking about limits. if you take a limit, okay, and you get 0 divided by 0, okay? So you take a limit, you see 0 over 0. If that happens, then you are going to have to do some algebra or some trick to figure out what happened, like what the limit is approaching. And that's exactly what we did, right, on the problem that we just looked at. When we were doing this, we got 0 over 0, right? When we tried just to evaluate, just plug 2 in, we got 0 over 0. That told us we've got to do some algebra. We did the algebra and we got an answer. So that limit summary page that you'll see here tells us how to handle all these different things that we're going to see. The only thing we've talked about so far is 0 over 0. We still have to talk about all these others though. What happens when we take a limit and we get infinity over infinity? Or what if we get this, or 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 this? There's a bunch of different scenarios that we can run into. Today is mostly going to be about 0 over 0, all right? And then we'll move on. But what I don't want you to take from this, and this is, I've had students do this before, is that somehow they think I'm telling them that we actually have a way of defining what 0 over 0 is. I'm not saying that. I'm saying 0 over 0 is still undefined, but in the limit, we can approach an answer. Okay, so there's a major distinction between those two things. All right. So what is question? Go ahead. Yes.
Wouldn't 0 times infinity just be 0?
Wouldn't what?
0 times infinity, wouldn't that just be 0?
Okay, so you noticed that on the formula sheet right there, right? 0 times infinity. Okay, so if you told me take the number 0 and multiply it times infinity, there's two things there. First of all, what is infinity, right? Like that's not a number, so I can't really multiply 0 times infinity.
Okay,
that's the first thing. The second thing is, again, this is a limit, right? I'm telling you this is what happens when we take a limit. So I'm not actually telling you 0 times infinity. I'm telling you something else. Let me try and see if I can illustrate this with an example. We're getting ahead of ourselves, but I want you to understand it since you asked. Let's say I take a limit and let's let x approach 2 again, okay? And then how am I going to do this? It's going to be hard to do because we haven't talked about it yet, but I'm going to try. What if I had x minus 2 here, okay? And then times, I need something that goes to infinity. Why don't I do this? 1 over, see, it's going to be hard for me to do this because I can't use anything other than 2. Sine of x minus 2. There we go. I'll make it happen. And I'll square it just so we are sure about it. Okay, so just think about what's happening here. If I just try to do direct substitution, let x go to 2, then 2 minus 2, right? That is going to 0, right? That is headed to 0. Now, again, let's make sure we understand. I'm not saying that is 0. I'm saying it's headed to 0 because I'm letting x approach 2. 2, it's never going to become 2, right? It's never actually going to be 2. So as long as I put a number in here that's not 2, like maybe it's 1.99999, and maybe there's like 59s there. If I do that minus 2, it's still a little number, right? But it's really small number. And then I come over here and I say, all right, if I try and plug 2 into this, 2 minus 2 is headed to 0. What is sine of a very small number? So what's sine of 0?
0.
0. Cosine 0. So sine of 0 is 0. So this is headed, the bottom here is headed to 0, right? Do y'all understand that? It's getting smaller and smaller and smaller. What happens when you take a number like 1 and divide it by a very small number? What happens to it?
Doesn't it approach infinity?
It gets big, right? It gets huge, right? Take a number and divide it by a small number, you get a big number. Take a number divided by a big number, you get a small number. We're going to talk more about this, but so what's happening here is this is headed to infinity, right? And we're trying to multiply them. So Hunter, to answer your question, yes, 0 times any number, like the number 0 times any number would be 0. But what I mean by 0 here is not 0. I mean something that's infinitesimally small times something that's like arbitrarily huge. And the question becomes like, what happens, right? It really actually depends on how small this is and how big this is. And so what we're going to learn is that sometimes in some problems, the answer to this will be 0. Sometimes the answer might be infinity. Or sometimes they almost like shake hands and agree, you know what, we're going to agree to just go to something else. And maybe the answer will be 2. Who knows? But each problem you have to look at individually. And unfortunately for us, every single one of these issues that could come up, every single one of these sort of, we call these later on, I will call, these are called indeterminate, oh, come on. Indeterminate forms. These are what we call the indeterminate forms of a limit. The word indeterminate means you can't tell, basically. You cannot determine what's going to happen. So if you take a limit and you get any of these forms right here, then we have to do some work. There's algebra ahead of us. But today, it's just about that 0 over 0, okay? And then once we get our heads wrapped around that a little bit, then we'll move on and do, you know, infinity over infinity, and then the rest of them. And these are going to start to progressively get more difficult, like the algebra and stuff. The tricks that we do are going to be more difficult. All right. With that said, pretty much the rest of class is just examples. All right. So I'm going to start throwing limits out here. And really what you want to see today is not necessarily, you don't want to sit there and be like, man, I would have never thought of that. Okay. Because most of the problems I'm going to put here, you probably would have never thought to do what I'm going to do. But once you've seen it, now you say, ah, okay, if I see something like that again, I've seen something done like this before, I might try that. All right. So here we go. The first one we're going to do, let's do the limit. Let's let x approach. I'm making this up on the fly here. X approach 4. And then let's do, I'm trying to determine how I want to go about this right now. Let's go x squared minus 4x over x squared minus x minus 12. All right, so anytime we have a limit, okay, anytime we ever see a limit in front of us, the first thing we want to do is try direct substitution. In other words, just try and plug 4 in for all the x's and see what happens. All right, so just replace all the x's with 4. So normally I like to do that like with a little arrow. And I just say, okay, let me replace everything with 4. So 4 squared minus 4 times 4 over, and then we get 4 squared minus 4 minus 12. So we should get 0 over 0. All right, 16 minus 16 over 16 minus 4 minus 12. So we get 0 over 0, right? As soon as we see this, we're thinking to ourselves, okay, this is bad. And so I need to do some algebra or some trick or some combination of an algebra and a trick, right? So what algebra can I do here? So how about the numerator? And also I should point one thing out here before we get too far ahead of ourselves. Let's just say that this would not have been 0 over 0. What if it was 0 over 5? Well, 0 divided by 5 is defined, right? 0 divided by 5 is 0. And so our answer would have just been 0. So the problem is not that we have a 0 on top. Okay, that's not the problem. The problem is that we have a 0 on the bottom. And that's what creates the issue. So algebra and a trick. So I look at that and I say, okay, what algebra can I do with that? Well, we learned how to factor, right? So in the numerator, I can factor an x out, greatest common factor. And on the denominator, well, that's a trinomial. So we learned how to factor trinomials in algebra. And I know they tell you in algebra, they're like, you better learn how to factor. And the reason is because when you get to calculus, you can't factor. Can't factor, then you can't ride the train. Okay. I mean, basically you're going to be in serious trouble as things proceed here. All right, so there we go. Do y'all see this now? Do you see that it can't, the factor cancels? Now, the factor that cancels is actually the one that's causing the problem, isn't it? It's that x minus 4 on the bottom. That's the one that's causing the division by 0. That's the one that when I plug in 4, I have a problem. So the fact that it's canceling is great, right? And I can cancel those again, as long as I promise that I'll never let x be 4. What I'm taking a limit. So that's kind of me making the promise right there. I'm going to let x get close to 4, but never be 4. So now at this point, we can rewrite the limit. I'm just going to write everything out with that, with everything canceled. So I have the x on top and I have x plus 3 on the bottom. And now at this point, go ahead and let x get close to 4. So what happens is the top gets really close to 4 and the bottom gets close to 4 plus 3. And so we get to 4/7. So let me ask a question. Alexander, are you here?
Yes, sir. I'm right here.
Where are you at? Where are you at? I heard you. I didn't see you. Oh, there you are, Alexander. Hey, how's it going, Alexander?
I'm doing pretty good, sir.
Okay. Oh, hey, I was gonna tell y'all, try when you're in the Zoom sessions, just make sure your name matches like what's on my, like, don't have like, sometimes people's screen will say like iPhone and I don't know who you are. Like last class, everyone that was here got a quiz grade, right? Remember that? We did a quiz at the beginning, but it was just an attendance. So I went back and I looked at the, like who was in the Zoom session and gave everyone 100. And I could tell who you all were. Okay, but just in the future, if you come in on a phone or something, just make sure that your name is appearing correctly. Okay, so Alexander, sorry, Alexander. So are we saying here that if you plug in 4, you get 4/7? Is that what we're saying?
No,
No, right? What are we saying?
we're saying that 4/7 is getting close to 4.
Other way around. As x gets close to 4, right? As x gets close to 4, this function gets close to 4/7, right?
Okay. Yes, sir.
Yep.
Mhm.
So I may not graph all of these, but you know, I'll do it for this one. Let's see. That should be the graph. Okay, so here's the graph of that function. And if I go to 4 on the x-axis, you can't tell. The computer doesn't do a good job. As good as technology is today, it still amazes me that they don't include these holes. Like you would think by now they would show the hole, right? There's a hole right here at 4. There it is. At 4, it's undefined. See? But as we come in from the left, right? As we come in from the left and we come in from the right, those y values are getting really, really close to, I don't know what that is. It's hard to tell. So let me just graph a horizontal line at 4/7. There's 4/7. So I think we can agree that we are approaching 4/7 from both sides. Y'all see that? We're getting closer and closer to it. So that would be very difficult to do, right? That would be very difficult to do without this concept of a limit in the algebra, right? Okay, any issues? So far, this is baby algebra. This is just factoring. It's not a big deal at all. Well,
I just got a question.
Yes.
So, like scenarios like this where you know you have to do algebra or something, when you have a hole, is it always going to be the I don't know what to call it, but whatever is it the ones that's always causing the hole that's going to cancel? Like, let's say, you know, you had another trinomial or whatever and something else canceled. Is that possible, or is that like, oh, you made a mistake somewhere? Or
See, there's a couple of things. It also depends on what your limit is approaching, right? So like if this limit was approaching 5, we would have no problems, right? Because the only problem we have is when x is approaching, or when x is 4. So if we did this limit and we said 5 here instead, then we're actually going to get an answer right off the bat. We're not going to get 0 to 0. So I think what you're asking is, will you always have issues where you have holes And I will say, yes, you will always have issues where you have holes, so long as that's what your limit is approaching. If your limit is approaching the hole, then you've got some work to do. Does that make sense, Ethan?
Yeah.
That looked like an agreeable, like just being agreeable there. You all right or no?
Yeah.
Okay. Look, if you want, we can talk about it a little bit later. Like if you kind of reformulate the question in a different way, maybe I'm not answering what you're asking. Okay, here we go. Let's do some more algebra. Let's do this one. Limit. Let's go to a negative number. We haven't done that. -3. And then let's do x minus 3 over 3 square root of 3 minus the square root of x. All right. Is it Kirian? Kirian? Am I saying that right?
Kieran.
Kirian? Okay, Kirian, you're up. So Kirian, what I do first, oh shit, hold on. We got to change this. Make it, sorry, I can't ask a question. Make it go to +3. That would have been a disaster because we had a square root. I'll do a negative number on another one. Okay, everyone got that? Change that to x goes to 3, not -3. That way this will work. Okay, Kirian, what do we do first?
We would plug them in with 3 and see if it works.
Yeah, to see what happens. Okay, so we plug in and what will we get? On top and bottom.
0 is 0.
0, 0, right? Well, 3 minus 3 over the square root of 3 minus square root of 3. And that's 0 to 0 is bad, right? Algebra trick. Okay. All right, now this is the first problem that I've shown you where there isn't some like kind of basic factoring thing, right? Like here, greatest common factor, denominator was just trinomial. You know, the previous problem was difference of squares. So, what do we do, right? Any ideas?
Do we try to input numbers like 2.999 and 3.001?
Okay, so the homework had y'all doing that, right? The homework had y'all like trying numbers and plugging in. So we are no longer going to do that. Okay, we're not going to just like try and plug numbers in. And the reason why is because there are certain functions that when you try that, you have to get really close to whatever the limit is. You have to get really close to it to be sure about the answer. Like I can give you functions that will behave a certain way because you're not getting close enough. So I guess it's just not it's not an efficient way, and it's not a way that you can depend on. Okay, so we have to do some algebra. We have
Did
to.
we
Conjugate.
yeah, that's what I was gonna say.
Conjugate. Okay, so the conjugate is something you learn about in algebra that you can always multiply top and bottom of a fraction by a conjugate, right? That's a legal action. That's a legal algebraic move. Okay, but let's see, does it actually do anything for us? Okay, because it may not. I mean, there's nothing that says that multiplying by the conjugate is going to make life better for us, but I'm going to do it because it is legal. I'm going to multiply the top and bottom of this by the conjugate of the bottom, which means I'm going to write √3 plus root x instead of √3 minus root x. And on the top, √3 plus root x also. So I'm just multiplying by 1, which doesn't change the problem, right? It leaves it the same. And now I'm going to multiply this all out, right? Going to multiply this all out. Now, this could be a mess. So here's what I'm doing. I'm going to write limit. Notice I keep writing the limit each time. Do y'all see that? Limit, 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 limit. Okay, this is proper notation. I will take off for improper notation because that's like you turning in a paper with no periods, no paragraphs, just a bunch of lines. I mean, just a bunch of words. Okay, there is proper notation in calculus. So we need to understand that the limit is always here until we get to that very last step where we have eliminated the problem and can let x get close to whatever we needed to get close to. Like in the previous problem, I did limit, 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 and it wasn't until this step right here, when I actually let X go to 4 is when I stopped writing the limit. All right, here we go. Now watch the way I do this, all right? I am not going to multiply out the top. I'm not going to, all right? I'm not going to do it. I'm just going to write it like this. Now, could I have multiplied out the top? Absolutely, I could have, but what? Just watch, okay? Now on the bottom, I am going to multiply those two together. Now, the beauty of the conjugate is that it's really a difference of squares formula. So what winds up happening here is when you multiply these together, the middle terms always cancel each other out. That's like the inherent property of the conjugate, is that when you multiply two things together, the middle terms are gone. So when I do √3 times √3, that just gives me 3. And then here, these middle terms, this one and this one, when I do those red multiplications, they kill each other off because they're opposite of one another. And then when I do that last multiplication, this one times this one, what would I get? Negative √x times positive √x.
Minus X.
Minus x. Okay, there we go. Now, at this point, are there any questions on that algebra? I mean, this is just algebra, but any questions on it? Right now, if you tried to do the limit again, at this point, if you try to do the limit, you will still get 0 over 0. Okay, if you can just try it right here. Plug 3 in here, you get 0. Plug in 3 right there, you get 0. So we still have a problem, right? We have not solved anything. We haven't fixed the issue, right? The issue was the 0 on the bottom, right? That 0 on the bottom was an issue. But do y'all see that these two are really, really kind of close to the same thing, aren't they? One of them is x minus 3, the other one is 3 minus x. So what I'm going to do is I'm just going to real quick over here convince you that 3 minus x is the same as -1 times -3 plus x. So I can factor a -1 out of that bottom expression, can't I? And if I want to go maybe one step further, I can maybe convince you that that's the same as this by just switching the order of this. Put the x here and the -3 here, right? So in actuality, this 3 minus x right here could be written as -1 times x minus 3. See, that's just me being clever, right? Because if I do it that way, then those cancel. And I have eliminated that division by 0 now, right? I've eliminated that part that's causing the problem. My next line, I'm going to write the limit again. I'm going to write what's left. So the only thing that's left on top is √3 plus √x. And the only thing left on the bottom is what?
-1.
-1. Don't forget that -1, right? We had that -1 right there. Any questions there? Okay, now try to let x go to 3. If we let x go to 3, we're going to get √3 plus √3 over -1. See, no more, I didn't write limit anymore, okay, because I let x go to 3, and I no longer have division by 0. I get 2 √3 over -1, which is the same as -2 √3. There it is. So Ricardo asked for, go ahead. Basil?
Yeah, I have a question.
Yes.
How did we get 2 and 3?
Oh, because you have two of these things, right? You have an apple plus an apple gives you 2 apples. Like these are like terms, so to speak. This is almost like x plus x is 2x. Is that what you're asking?
Yeah.
Does that make sense?
Yeah.
Like they're like radicals. So if you have the same root, same thing underneath, you can add them together. You just have to add their coefficients, and their coefficients are the numbers in front. So one of these plus one of those is 2 of them.
Okay.
Good. Thank you for asking that question, because I promise you there's someone else in here who's asking the same, or wondering the same thing. What's that?
I have a quick question.
Yes.
Would it be acceptable to write this as a decimal as well?
Okay, so I was gonna say, Ricardo had asked earlier, could we just start plugging numbers in, like 2.99, right? Right, that's what Ricardo, and I said, you know what, we need to step away from that. Part of the reason we want to step away from it too is because we want exact answers. Okay, we want the exact answer. We don't want a decimal answer. We want the exact answer. There's a big difference between an exact answer and an approximate answer. Whenever you have decimals, you're approximating for the most part. Like when you write, let's just make up a number, √2, okay? √2 is √2. If you go on your calculator is gonna say that's 1.414, and then it has a bunch of decimals. But in reality, this decimal keeps going forever, and it doesn't have a pattern. It doesn't repeat. It's not like the fraction 1/4. 1/4 is 0.25 and stops. 1/3 is 0.333 and continues. These are rational numbers. Those are fractions. This is an example of an irrational number. And what makes an irrational number irrational is the fact that it's decimal. When you write as a decimal, there's no repeating and it never stops. So we call irrational numbers numbers that have a non-repeating, non-terminating decimal. And all rational numbers, all fractions, will either stop, terminate, like 0.25, or they will repeat forever. Okay, we're getting off topic, but so the answer is no. Don't do a decimal, leave it as the exact. This is called the exact form. As opposed to, if you did your calculator, that would be an approximate answer. So I'm not going to graph this one. Okay, I'm not going to graph it, but you would just have to trust that if I did graph this and we got really close to 3, that the y values of this function would be getting really close to this, which would be a negative number, but that's what it would be. Okay, we good? Now, to do this problem, somebody said, let's do the conjugate. So I'm not sure what motivated that. Either they've done this before or they just have seen conjugates before and they were useful in the past. Maybe they'll be useful now, but it worked, right? It worked. So now that's something you now know, right? If you see something 0 is 0 and you've got some square roots involved, maybe you do a conjugate, maybe that helps. Maybe it doesn't. Maybe you do it and it gets worse. I don't know. I can't promise you anything. There's no like cookie cutter way to do these. So you need to be ready to like make mistakes, start over, try something else. Okay. All right. I want to show you that same problem done differently. So I like to tell students that, and I may have said this to you already, that I've always believed that the ideas of calculus are not that difficult. Like when in the beginning of class, I said, hey, we have a function and we're trying to find this line, right? The slope of this line at a point. Like that's pretty easy geometrically to see. Doing it is harder, right? And believe it or not, this is actually going to get us there. What we're doing right now is going to get us there. But I always say that the concepts are pretty easy. It's the algebra. I always say calculus is like algebra on steroids. So watch what I'm going to do. All right. Again, this is me doing this. You may not have ever thought to do this, but now you're going to see me do it. And you're going, oh, okay, I guess I can do that. So look at this right here. Okay. That is a difference of squares. No, it's not. Yes, it is. Okay, here it is. Square root of x plus the square root of 3 times the square root of x minus the square root of 3. That's what it is. Do you believe that? Well, multiply it out if you don't believe it. It is, though. It is. Okay. So when you've learned in the past difference of squares, something like this, x squared minus 9, most students are comfortable with the idea that this is x plus 3, x minus 3. Because they've seen it so many times, they're like, oh yeah, that's simple, right? But in reality, what are you doing? You're taking whatever that is, right? And you're taking its square root. What's the square root of x squared? X, right? And you're putting it here and here. And then you're doing plus and minus, and then you're doing this number and you're taking the square root of that, which is 3, and you're putting it here and here. So like in general, if you ever have two things being subtracted, let's call it A and call it B, doesn't matter what they are. Neither one of them even have to be perfect squares. This will always factor to be the square root of the A plus the square root of the B times the square root of the A minus the square root of the B. And if you FOIL this out, you will convince yourself, hopefully, that this is this, A minus B. So that's what I mean by algebra on steroids, is that difference of squares, this is the college algebra version of difference of squares. But this is the more abstract, universal kind of difference of squares approach. So are y'all convinced that this is x minus 3 on top?
Yes.
Okay, so now instead what I'm going to do is just rewrite that on top. On the bottom is square root of 3 minus square root of x. And now, again, like before, these two are almost the same. They're almost the same. This one has a positive root 3. That one has a negative root 3. This one has a positive root x. This one has a negative root x. So they're off by a sign. Do y'all see that? They're off by a sign. So anytime you have a factor that's off by a sign, you can always pull out a -1 and then get them to cancel. So that's what I'm going to do now. I'm going to say this. I'm going to pull the -1 out. That'll leave me negative root 3 plus root x instead of minus root x. So there's my -1 getting pulled out. And now these two are the same. They can cancel. The order doesn't matter because they're exactly the same in terms of the sign in front of each of them. And if you do that, then we're going to be exactly where we were on the last problem. Who has a question? Anyone?
That's really cool.
Yeah. Yeah. Now, what would have motivated me to do that? Well, I would have to kind of already mentally know what this looks like, right? Like I would have to kind of know what the difference of squares of this looks like and see that it's almost this. Like I have to be that far ahead of myself. Does that make sense? Like I'm not just like randomly doing difference of squares just because. It's because I see the denominator looks like this thing broken down into its difference of squares. So that's what pushed me down this road. Now the conjugate works just fine too, all right? So, you know, go with the conjugate. Shit, I don't care. Just make sure the algebra is good and you're fine. So there might be more than one path to the same result. Ready for next one? How about this? Limit x approaches, I'll do a negative this time, -5. Let's do 1 over x squared minus 1 over 25, all of that over x plus 5. I'm going to give you a minute just to mess with it, kind of mentally, and just think about it. And then I'm just going to refill my drink and I'll be right back. And then I'll call on someone and see what they've got so far. We'll go maybe 30 more seconds. Okay. Jacob, you there? Or Jake, you go by Jake?
Either one works.
I'll type Jake on my side since that's what you have on your screen. All right, Jake, doing okay with this? I mean, in terms of like understanding like the general idea here?
Yeah, just a little stuck on this one still.
Okay.
Thinking actually,
What'd you do first?
I haven't done anything. I just wrote
No?
it down. I was thinking it over still.
Okay, so Jake, what's the first step for any limit?
I mean, try to plug it in.
Yeah, just plug it in. Okay, so just see what happens when you plug it in. So if we try that, let me see. You get 1 over, and you got a square -5, right? So -5, that gives us 25 minus 1 over 25, then all over -5 plus 5. And Jake, is that clear at 0 over 0?
Yeah, I could just tell that by looking at it. So
Okay, so you didn't need to write it. That's fine. So it's bad. It's algebra. But I just want to make sure everyone understands, like, always check this, okay? Do not ever assume that a limit's going to give you 0 over 0. Sometimes, not all the time, but sometimes on your test, your first test, I'll give you a limit where there is no problem. And students will start doing all this weird factoring and stuff, and they try and they realize at the end, like, there was never an issue. Like, it was never 0 over 0. So if it's, you know, if you do a limit and you get 2/3, then the answer is 2/3. It's only when you get that 0 on the bottom that we have a problem. Okay, so yeah, so we're here, Jake, and you know, we look at this and it's just like, what do you do, right? What do you do? So my recommendation for this is this. If you ever see a complex fraction, which is what we're looking at here, complex fraction is just a fraction that has fractions within the fraction, right? So we've got like a fraction, fractions on top, but that's all part of a bigger fraction. This is a complex fraction. My recommendation is to always try and put these two together. So get a common denominator between those two. So to get a common denominator, you have to multiply the first fraction by 25 over 25. And you have to multiply the second fraction by x squared over x squared. In doing this, we're creating the same denominator in both fractions, and then we can put them together. That makes sense to everyone? So if I do that, I will get the 25 times 1, which is 25. I can then subtract from that the other numerator, which will be just x squared. But then all of that will be divided by the common denominator, which we created with 25x squared. But then all of that is still divided by the x plus 5. We good there, everyone? Now, Isabella?
I'm here.
So do you see anything that maybe we could do here? Recognize anything?
I'm noticing that on the very top fraction, those numbers are looking a lot like each other.
Okay. Do you recognize this right here? You have a difference, right? Of these are both squares, right? This is a difference of squares.
Yes.
So we could factor that, couldn't we?
Yes, you could.
Okay, let's see what happens. I mean, this is kind of like the lottery, right? You can't win the lottery if you don't play, right? You're not going to be able to get to an answer here if you don't play, if you don't try something. You got to be willing to put something down on paper. So I'm going to go and put 5 plus x, 5 minus x. That's the difference of squares over the 25x squared. But then all of that is over the negative x plus 5. Isabella, that's algebraically, that's okay, right?
It wasn't a negative x plus 5.
Well, what did I do? Oh, oops, sorry. Yeah, you're right. Thank you. Otherwise, we're good? Yes?
Otherwise, yes.
Okay. So now a very interesting part, okay? And this is really just going to go back to kind of like your understanding of fractions. this 5 plus x and this x plus 5 will cancel. Right now, they will cancel. But I want to make sure everyone understands why, right? Because I know there's people in here who don't understand this cancellation. So I'm going to rewrite the bottom as this, x plus 5 over 1. And that way, I'm looking at it as a fraction divided by a fraction. And anytime you divide two fractions, it's the same as multiplying by the reciprocal, right? Division of two fractions is the same as multiplication of the reciprocal. So that means this really becomes limit x approaches -5 of 5 plus, 5 plus x, 5 minus x over the 25x squared times the reciprocal of this one, which puts a 1 on top and then x plus 5 on the bottom. And I hope that then you can see that this and this cancel. Now, if you're comfortable with that and you already know that and you're not going to mess it up, then feel free to cancel them here. I don't mind you canceling them here. You just have to be real careful. I can remember as a student having a little bit of an issue with that. So after I did this enough, I got comfortable to the point where I knew what would cancel and what wouldn't. All right. So there we are. We've canceled the thing that's causing the problem. So I'm just going to rewrite it one more time. 5 minus x on top. And the only thing left on the bottom is 25x squared. And now at this point, let's let x go to -5. So no more limit. No more limit. 5 minus -5 over 25 times -5 squared. So the top becomes 10. And that's 25 times 25. Because when you square -5, you get 25. And what's 25 squared? I mean, sorry, 25.
625.
625.
625. So we have 10 over 625. And that reduces, doesn't it? 5 goes into both of those.
I got 2 over 125.
2 over 125. There we go. How are y'all feeling? I mean, what are y'all thinking about this? How's it looking? I mean, I've been doing limits for like 30 years. So for me, it's, you know, I don't even remember what it's like to see it for the first time, but you know, can you see? Yeah, go ahead. Go ahead.
Is it possible that we can get more and more practice with these?
Oh, absolutely. That's what your homework, that's what your homework is going to be. Is that what you're asking?
Yeah, I ran out of problems though. And
Oh, you did?
It doesn't regenerate questions though, the textbook.
Okay. Yeah, so what I would do, all right, is I would take advantage of what you have out there that I didn't have when I was taking this, which is the damn internet, right? So just go to Google and just be like, practice limit, you know, problems Cal 1. And I'm sure you'll find multiple worksheets that you can, you know, find with problem sets on them with solutions. Yeah, I mean, there's so much out there. Let's do it. Cal 1. Limits practice. There we go. Oh, this guy has good notes, online notes, Paul. Let's see. Khan Academy now. I like to go to like just like random like universities. Like here's, I've never heard of that. Let's just take a look. Let's add PDF to it so we can download it. Here's a worksheet on limits. All right, so this has, oh, there you go. There are a bunch of freaking limits right there. My goodness. Okay, there's a bunch of them. I'll put this in the chat. Okay, now I haven't reviewed it. Okay, but and I don't think you could do all those yet. but that would be something you could probably do the first, like A through, let me look at them real quick. You could do A through P. Everything A through P could be done. Let me put it in the chat.
Did
Is
it
that
have the
okay?
solutions? Did it have the solutions to it?
I don't know, did it?
I didn't see it.
I don't know. You can look at the file. The file's 60 pages long. So I think it's 60 pages. Let me put it in here. But my point is just go look up problems, you know, because there's no such thing as too much. Oh, that was a review of all Cal 1. So yeah, I don't know what you're getting there. But there's just so much out there that you can find. All right, you ready for some more?
Yes.
So this is a good example of how I could show you 100 problems today, and then send you home with a problem that we haven't done. Okay, so everything is kind of unique, but there is kind of a like I said, like a flavor to these. There's kind of like a spirit behind all of these that you just have to have some persistence and be confident in your algebra and try and do some of the things that I'm doing here to see what happens. Okay, let's let X go to 1. And then let's do the square root of X plus 8 minus 3 over X squared minus 9. Oh, hold on. X squared minus, I messed that up. In my mind, I don't know why I was going to 3. X squared minus 1. X squared minus 1, not 9. You'll see that. Okay, so I'm going to try and do this one in my head a little bit. If I let X go to 1, 1 plus 8 is 9. Square root of 9 is 3. 3 minus 3 is 0. 1 squared is 1, minus 1 is 0. So I have 0, 0. Okay, this is bad. Algebra. Trick. Okay, so look, like I said, I've been teaching this for a long time. I'm actually, I think it's 2021, right? I finished my master's in 2001. I was teaching calculus already at that point. So in my 20 years of doing this, I think almost inevitably, like not without fail, okay? Without fail, somebody on the first test is going to do this, get 0 over 0, and they're going to tell me the answer is 1. It's going to happen. Which of you is it going to be? Which of you is it going to be? Are y'all going to be the first class to ever not tell me that that's 1? Someone's going to, right? Someone's going to. And for me, that is just like a fundamental not understanding what's going on here. Like 0 over 0 is the whole reason we're here, is because we're trying to figure out what's going on. So to say that that's 1 is just, yeah, there's a huge gap when I see that. All right, anybody, let me see, let me call on someone. I'm trying to get through everyone. Angel?
Yes, hello, sir.
Yes, what you got? You have any ideas on that?
Yeah, sorry. I don't really have any way to break up that square root, but the only thing I really did was split up the, what is it, to X plus 1 and then X minus 1. I'm
Okay.
trying to see what I can do, but I don't know.
So I'm okay with that. I'm okay with you not doing anything up there yet. And then on the bottom, I'm okay with you saying that that's X plus 1, X minus 1.
Mm-hmm.
Okay, I'm all right with that. You all okay with that? I mean, that's not wrong, but it doesn't fix anything, but it's not wrong, right? All right, Angel. So you see a square root in here, right?
Yes, sir.
So earlier, when we were doing a problem, we saw some square roots and then we did something. Do you remember what we did? Like we did it one way and then I did it another way. And I wasn't sure why the people had suggested it, but I said, yeah, it'll work. They're like, it does work.
The way that you like split it up, where you made it into like
Where is it? Let me see. It was this one here. No, wait. Was it this one? No, that's the way I did it. The one, oh, here it is.
yeah.
Yeah, so we had some square roots in here, right? And then
Oh,
someone
yeah.
told me to do this. I don't remember who told me, but somebody told me to do this. The
Mm,
conjugate, right?
Yeah.
Conjugate. So why don't we try it? Okay, let's just try the conjugate. Now, when we say conjugate, what I mean is the conjugate of the top, not the bottom. All right, let's do this. Square root of x plus 8 minus 3 instead. And on the bottom, multiply by the same thing.
Wouldn't it be +3 in
It
the
would be
conjugate?
plus.
Yeah, plus, sorry. Plus. The problem with being left-handed sometimes I can't see what's underneath what I'm writing. So yeah, plus. There we go. So I'm trying this because it might work. Okay, it may not, but it might work. And we've done this in the past with success. So maybe this will work. All right, now I'm going to multiply out the top. Okay, now that one I'm going to multiply out because that's where the conjugate's coming from, right? So I know that when I do this, I'm going to get this times this, which means the root's going to go away, right? So you're just going to get the x plus 8. Now the middle terms, when I do this one, right, and I do that one, when I do those multiplications, the middle and then the outers, those will kill each other off. Again, because that's what the conjugate does. So all I'm really concerned about now is that last multiplication, -3 times 3, that should give me -9, shouldn't it? Everyone good with that?
Yes, sir.
Now, all of that is over. Now, on the bottom, I am not multiplying anything out, okay? Now, the reason I'm not going to multiply this out is because first, it's going to get really ugly. But second, if you try and multiply all of this out, what you're going to do is you're going to unintentionally hide the thing you're trying to cancel. The thing I'm trying to get to go away is this, because that's the thing that has the 0 in it, right? When x goes to 1, that's the part that goes to 0. So I don't want to start multiplying this all together and lose that factor. So I'm leaving it there. And I don't know, it's almost like a miracle, right? That the numerator actually turns out to be x minus 1. Right? X plus 8 minus 9 is x minus 1. And now that cancels out with the x minus 1 that's causing the problem. And that's wonderful. Because now I can take this limit as x approaches 1. Now what's still on the top?
1.
1, right? Because we canceled everything. That still means we have a fraction. Then on the bottom, I have the x plus 1. And then I also have in that other parentheses square root of x plus 8 plus 3. And now at this point, I let x go to 1. Okay, so I'm going to let x go to 1 now, and I'm going to get 1 over. So no more limit. I get 1 plus 1 times the square root of 1 plus 8 plus 3. 1 plus 1 is 2. And then this is going to be 9. Square root of 9 is 3. 3 plus 3 is 6. So 2 times 6. So this is 1/12. All right. How y'all doing?
I have a
Okay.
question.
Yes.
On the part where you canceled out x minus 1, how did you know that that would cancel out?
You mean at what point? I'm not
At
sure.
the x plus 8 minus 9?
Well, that is x minus 1, right? X plus 8 minus 9 is X minus 1?
Oh, I'm sorry.
Is that what you're asking?
Yeah, that's what I was asking. Oh, I'm
Oh,
sorry. I
okay.
just figured
Yeah.
it out.
No, it's okay, because if you don't see it, then obviously it's going to look like magic, right? That's just algebraically, that's X minus 1. And then
Okay.
that just turns in, that just cancels out. Now, how did I know that? I didn't know that the top was going to turn into X minus 1. I didn't know that. But I had a pretty good hunch that it was going to do something good because, well, I knew it was going to work because I've been doing this for a long time. You didn't know that, but again, this is where you have to actually step up to the plate, take a swing, right? You can't hit the ball if you don't take a swing. So you have to try something. This happened to work. But the conjugate was the key, right? The conjugate. So both times we've seen square roots like this, the conjugate has been successful. So that just might be something you're going to keep in your mind now. When you see roots, think conjugate. All right, keep going. Let's do another one.
I have a question.
Yes.
How did we get to 2 times 6?
Okay, so I did 1 plus 8 is 9, right?
Mm-hmm.
Square root of 9 is 3. So
Yeah.
this is 3 plus 3, and that gives me 6. And then this gives me 2.
Oh, okay.
So as soon as you get rid of whatever made it 0 on the bottom, that's when you just plug it in.
Yep. As soon as you can get rid of the thing causing division by 0, you should be like home free at that point. The challenge is to get that factor to cancel, whatever it is. If you go back here, it was the X minus 1, we needed that to cancel, right? On the previous problem, let's see, what was the thing that was causing the issue here? The thing causing the issue on this one was this X plus 5, because when I plugged in -5, I got 0. And right here, I got it to cancel. On the one before that, this one, this was 0 on the bottom. And we got it to cancel right here in this step. And if you go back and look at all of them, that was happening all the time, right? This was going to 0, and then boom, right here, we got it to cancel. Where was it? Well, when we multiply out, it was this one and this one that canceled. So every one of these, yeah, at the heart of the problem is trying to get the thing that's causing the division by 0 to go away. All right, here. Okay, 1 over 2 root x minus 1 over 4 over 4 minus x. It's 204. I'm going to give y'all like 6-7 minutes, see how far you can get with it. Let me just make sure I did it right. It is 0 over 0, right? Yeah. Okay. So I think what I'm gonna do is I'm gonna start working it out silently. And you can kind of look up to see if you're on the same track there. Okay, I've put my work up here. If you were able to get to that, good job. If you weren't, it's okay. This isn't a test yet. So first thing I did is got a common denominator between the two, right? Because I said, if you have complex fractions, try and get them put together. So I looked at the denominators. I had a 4 and a 2 in both of them, right? So I need a 4, at least a 4. And then I have a root x here, so I'll need a root x on this one. So I multiply this top and bottom by 2, and this top and bottom by root x, and then combine them together. You got this. The next key thing I saw was that 2 minus root x, that looks like what this would turn into if I did the difference of squares. So I had to kind of know that, you know, I had to see that mentally. And since it's the second one I've done like that, hopefully you are now starting to think a little bit that way. So I just rewrote this 4 minus x this way, and then right there it cancels. Right here. If you don't like that step, like you could do this if it helps you. To rewrite it like this, 2 minus root x over 4 root x. And then look at that bottom as a fraction. And then flip it over like this, 1 over 2 root x, 2 minus root x. If that helps, then you can see the cancellation maybe a little bit better. And then this is actually easier to do. If you plug in 4 now, you'll actually get 1 over 32 a lot easier. Are there questions on that?
I do have one.
Okay, go ahead, Jasmine.
So I was on the right track with everything. The only thing that threw me off was the difference of squares. So when I did it, I did just x. I didn't do the square root of x. So I was just wondering like where that came from, or how do I know when to put the square root of x?
Okay, well, in the formula for difference of squares, what you're always going to do is the two numbers that go, or the two things that go here, right? The first two are always the square root of that first one.
Mhm.
And then the two things that go here are always the square root of that second one. So if this is x, then it's got to be root x and root x.
Oh, okay.
Think about this. If you do x squared minus 9 is x plus 3x minus 3, I'm assuming you're comfortable with that. What you're really doing is this and this is the square root of that, right? Square root of x squared is x. So that's what you're putting here. And then the 3 comes from the square root of the 9 here and here. So if you have just an x here, then you're going to have a root x.
Okay.
Got it?
Yeah, that makes more sense. Thank you.
Okay. Now, I will say also, oh, go ahead.
I was gonna say, can you explain the common denominator part? Because I tried something similar, but I multiplied each side by its denominator, and I don't know, I didn't get that.
Okay, so you did like 4 here, 4 here,
Yeah.
2 root x, 2 root x.
Yeah.
Yeah, so everything should have still worked out. You should have had on top, you should have had a 4 minus 2 root x over 8 root x, and then over 4 minus x. Is that what you had?
Yeah.
Yeah, okay, so the thing that's bad about this is you have to realize now that on this top one, you could pull a 2 out. See, if you pull a 2 out of the top one, then you can get the cancellation to happen.
That is what I did.
Oh, you did? Okay.
Yeah.
Then you should get the same answer. Did you have an 8 root x on the bottom or 4 root x?
No, I have 8 root x. I have that.
Okay. That should have worked.
I did that same thing.
I got
and
stuck
then-
right there. Once
did
exactly what
I.
you have, I got stuck.
Okay, so hold on. Let me go. I have to do this on a new page. So here's where you were. You were at limit x approaches 4. You had pulled a 2 out. You had 2 minus root x, then all over 8 root x, and then all over 4 minus x, right?
Yep, exactly.
Okay, and then did you turn the 4 minus x into a difference of squares?
Okay, maybe I shouldn't say that. That's what I messed up.
Okay, so look, while we're here, let me show something else that would have worked also. Conjugate. Okay, conjugate would have worked here too. If you take this and you multiply by 2 plus root x over 2 plus root x right here. See the little I'm going to do the conjugate of this one. Right here on top and bottom. Watch what happens. When I multiply here to here, and the middle terms go away, I get here to here, watch. I get 2, and then this will be 4. And then middle terms are gone, and I get minus root x times positive root x. That gives me minus x. Y'all see that right there? Now my denominator is going to be below that, is going to be the 8 root x. That's this. Then I still have this next to it, 2 plus root x. And then all of that is still over the 4 minus x. And these factors cancel.
Okay.
They cancel. Now you can plug in 4 for x and you'll still get 1 over 32.
And then for the other way they did without the conjugates, you said you broke up the 2 minus root, or what would you break up to get that?
4 minus x. I broke it up to be 2 plus root x, 2 minus root x. Yeah, so, calculus promises algebra. and it always delivers, right? I mean, it will always deliver. It'll always test your ability to manipulate expressions. So it's good practice. I mean, you're going to get better at algebra. You're going to get better. You have no choice. All right. All right. Time is it? Okay, we still have 23 minutes. So I'm trying to look at what else. There's so many different problems we can do. I feel like I've given you enough to at least launch you here, okay? Like you can at least get going on the homework on this, and then I'm going to anticipate that there might be questions, all right? But there's another part of this section that we have to discuss, all right? And it involves doing limits where the algebra isn't there, okay? In other words, we don't have algebra to be able to solve the problem. I'll give you an example, all right? So let's look at this one. The limit as x goes to 0 of sine of 4x over tangent of 3x. So like we did with all limits, we always just try and see what happens if we plug in 0 for x in this case. So this is going to be sine of 0 over tangent of 0. And we all know that sine of 0 is 0. And we all know that tangent of 0 is 0. Or at least we would know if we were given enough time, all right? So that means we need to do some algebra or trick, right? But there is no algebra that we can do, all right? Please do not cancel these x's, all right? Do not cancel those x's. Those x's are trapped. The 4x and the 3x are both trapped within the trig function. So we should know this before we came into this class. If you have something like sine of 3x, or sorry, let's do the 4x because that's what's up there. If I have that, please, this is not for sine of x, right? You cannot just pull numbers out of the trig function like this. It's not the way trig functions work. The argument, the thing that's plugged inside, is pretty much trapped. You can't get it out of there. Now, there are some formulas that allow us to do things like, we do have this formula from pre-cal. It's called the double angle formula. Now that one, that is true, okay, but that's a formula. This in general is like this right here is like someone trying to do algebra, like pull a 4 out. Can't do it, okay, can't do it. So we have at this point, we have no way of doing this problem. All right, there's no algebra that you can do to make things like become better. All right. So that leads me to two very important limits. Two important limits. So here they are. The first one is this. The limit as x goes to 0 of sine of x over x equals 1. Now, I just want to tell you something about this limit. I'm not here to prove to you right now why this limit is equal to 1. Because if you try and plug 0 in right now, 0 in for sine and 0 down here, you will get 0 over 0. Okay? You'll get 0 over 0, and that'll be bad, and we'll need to do some algebra, which we can't do. But this limit has already been done. Okay, it's been proven, and the answer is 1. And if you don't believe it, or if you would like to believe it visually, I'll just graph that function, and then hopefully you'll agree. If I take sine x, I divide that by x, here's the graph of sine x over x. And is it clear to you that as we approach 0 from the left and the right, it's headed to 1? And
yeah,
you see
that seems pretty clear.
Yeah, if I plug in 0, it's undefined. 0 to 0. Okay, so the limit is 1, but I'm not telling you why other than visually. So take that on faith, but rest assured, I will prove this limit to you later. in this class. I will prove it to you. And when I prove it to you, you'll be like, okay. Well, actually, you're gonna be mad at me when I prove it to you, but it'll be for another reason. Okay, so there's the first important limit. And then the second important limit you need to know is the limit as x approaches 0 of cosine x minus 1 over x, that limit is 0. Know these. Okay, know these. So on the second one, again, I'll graph it for you just so you can be convinced that it's true. So if I take cosine x minus 1, divide that by x, it's the blue graph. And again, I hope you agree that as you approach 0 from the left and the right, it's headed to 0. If we try and plug 0 in, we're undefined. Okay. But no proof, no proof. You just take that on faith. Now, that's the way the book presents it, okay? I have a slightly different way that I want you to look at these limits, and it's going to be vital to you doing well with the next set of problems. Instead of you looking at it like this, all right, I want you to look at it more abstractly. What this formula or what this limit is saying is this. Let's say you're taking a limit, okay? And I don't care what's happening here, all right? Like it can be x is approaching 5, it can be x is approaching 0. I don't care what it's going to, okay? Let's all just, who cares? But we are taking a limit. And let's say on the top you have sine, and inside of that sine, you've got some expression in here. I'm not even gonna say it's x, okay? It's not x like up here. I'm just gonna say it's some expression. Let's say, we'll call it junk, okay? This is junk right here, whatever it is. It could be x, could be x plus 2, could be natural log of x, whatever, it's something, right? So let's say you have sine of some junk over, and on the bottom, you have the exact same junk. So the quotes mean these are exactly the same, all right? So if this is x, then this is x. If this is x squared, this is x squared. If this is 2 minus x, this is 2 minus x. If that's the case, then the answer to this will be 1. Okay, the answer to this will be 1 if the junk is headed to 0. Okay, I will explain this when we do an example. That's the way I want you to understand that first one. We'll get to the second one maybe next class. So let me show you what I mean by this below. As an example, if I were to write the limit as x approaches 0 of sine of x over x and ask you what this limit is, what you would do is you say, hey, I've got sine of some junk over some junk, right? That junk matches exactly, right? X and x. And does that junk go to 0? So is x going to 0 in this problem? Well, yeah, right? That's the junk, right? That's the junk. The junk is x. The junk is going to 0. And that means my answer is 1. Now, if that doesn't make sense because it's almost too easy, here's another example. Let's say limit x approaches 2 of sine of x minus 2 over x minus 2. This answer would also be 1. Let's see why. Well, that junk and that junk match, right? X minus 2, x minus 2. They match exactly. Now, is the junk going to 0? Well, let x go to 2, right? Let x go to 2. Does that go to 0? Do the yellow things go to 0? Yeah, they do, right? So the answer is 1.
Could you repeat that? Wait, I'm kind of.
Yeah.
You said if the limit is going to 0?
Okay, so the junk has to match, okay? We have to have sine of junk over junk. So these two things have to match exactly, which they do, yes? Now,
Yes.
When we take this limit, okay, here's the limit. We're gonna let x go to 2. So Daniel, when we let x go to 2, does the junk part go to 0? Does the yellow part go to 0?
Okay, so it's not just x going to 0, it's both sides going to 0.
They both have to go to 0, yes.
Okay.
And they have to match. They have to be exactly the same. Which they are, right? This is x minus 2, this is x minus 2. So both of these match. And when I let x go to 2, that goes to 0 and that goes to 0. So therefore the answer is 1. I'm going to give you another one. How about this? Limit x goes to 0 of sine of 4x over x. Be very careful here. Do we have sine of junk over junk?
No.
No.
They don't match, do they? Do y'all see these don't match? This and this don't match. So you cannot tell me that this goes to 1 because they don't match. All right. You okay with that? If let's just say they were both 4x, then would it go to 1?
Yes.
Yes, because they would match, and when I let x go to 0, they would both go to 0, wouldn't they? If it were 4x, right? If it were 4x on the bottom. If it were 4x. It is 4x on the bottom. Is it not? No, it's not 4x, is it?
I mean, this is the part where this little funny math comes in right here. This is the part I didn't
Funny
get.
math right here. You ready? I'm gonna just do something very simple. I'm gonna take this and multiply top and bottom by 4. Okay, that's
I was
legal.
expecting that.
Yeah, that's legal, right? I can do that. That's a legal move. I can multiply by 1, nothing changes. But watch what changes now. I'm going to take, remember, these are fractions, right? So when we multiply fractions, we go straight across. So I am free to move that 4 next to the x and make that a 4x, right? Can I do that? That's legal. That's a legal algebraic move. And then over here, I'm just going to leave the 4 up here and just make it 4 over 1.
Yeah, I don't get that. That's weird.
It is weird. But do you agree that if I had a 4 over 4 here, that I could just move this 4 here and leave this 4 here?
I've never seen that before. I don't get that. I thought if
That's weird, yeah.
that's super weird.
Well, think about this. If I gave you 2 fractions, right, 3/4, and I said multiply that times 5/7, right? You're supposed to multiply straight across, aren't you?
Correct.
Okay, so you're supposed to do 3 times 5 over 4 times 7. But I don't have to multiply the 3 times 5. Like I could just do the 4 times 7. I could just make this 3 over 4 times 7 and leave the 5 as 5 over 1. This will give you the same answer, right? This is 3 over 28 times 5 over 1. It's the same result as going 15 on the top, 28 on the bottom. You still have the same thing, don't you?
Yes.
So it's not natural. I mean, I will agree it's not natural, but it is legal. Like it's a legal algebraic move. And that's all I'm doing. I'm just saying 4 over 4. I push this 4 here, make it a 1 down here, and it's the same thing.
What do you call this though? It has to have a name to this.
Doesn't.
Wow. Okay.
Algebra. It's algebra. So it's just really, it's doing something we've been doing for a long time. We're just realizing that there's a 1 next to everything, right? There's always a 1 being multiplied times everything. So what I'm doing is I'm looking at the original problem, right? The original problem was in red here. And I said, man, sine of 4x over x, sine of junk over junk, the junk's going 0. The junk doesn't match. I really wish that that was a 4x. I wish it was, right? Oh, I'll just make it a 4x. You see, I'm making it into what I want it to be. And now let's talk about it. Is this sine of junk over junk? Does the junk match? Does the junk go to 0?
Yes.
Yeah. Okay. So that means if I take this limit goes to 1 times. Now, if I take this limit, there are no x's in this expression, right? X is going to 0. 4 over 1 is just 4. So your answer is 4. Now, I want to point something out. Let's start this problem over.
Is this still part of 1.4 or is this the next
This is
lesson?
still part of 1.4, yes. So I haven't told y'all this, but this book that this course is based on is called The Essentials of Calculus. And it's written by an author named James Stewart. Okay, he's written so many books. And he's a great author. Thing I don't like about this book is that this is a great book if you've learned calculus and then you want to have like one book on your shelf for calculus as a reference, because the problem sets in here are limited. In text, like the textbook I learned out of, this topic that we're talking about right now was like an entire section in the book because it's so abstractly different than everything else. In this book, it's just like 4 problems at the end of the section. I've always hated that about this book, but we'll be okay. We'll be okay. All right, back to this. So let's say we start this problem over and we're sitting here, and let's say a student writes this on the next line. And then they do this. Do I give them credit?
No,
Why?
because you already said that that's an illegal move, the 4 times
It's illegal,
X.
right? You pulled the 4 out of the sign. That's not legal. But I got the right answer. You got lucky. Okay, you got lucky. Like it just so happened to work. All right.
Yeah, it could have.
I was gonna ask you that, 'cause-
Yeah, this is no good. All right. So let me do something else. You ready for another one? We only have 6 minutes. Let me try another one. How about this? Limit x approaches 0 of sine of x over 4x. All right, so do we have sine of junk over junk? Does the junk match and does the junk go to 0?
Doesn't match.
Doesn't match, right? Dang it. It would be real nice if that was a 4x in there, wouldn't it? But I can't push a 4x in there. There's no way I can get a 4x in there because the sine functions, they're complicated. You can't just push numbers into them. But this problem is almost so easy, it's difficult, because what I can do is I can just pull that 4 off the bottom. Right? I mean, that's the same thing. If I do 1 times sine x, I get sine x, and if I do 4 times x, I get 4x. So I just slid that 4 out to the side, and now this I know goes to 1, and this goes to 1/4, and 1/4 times 1 is 1/4. So in both of these problems, they're kind of different, right? In the first problem, I didn't have a 4 down there. I really wanted a 4 down there, and so I made a 4 appear. In this problem, I had a 4 down here. I didn't want the 4 down here, but because of multiplication, I can just pull that thing out to the side. And now I think we're ready for the more difficult problems. Here we go. I have maybe can do this one. All right, if we run through this real quick and we run the limit sine of 0, 0, right? On the top and the bottom. So if I let x go to 0, I'm going to get 0 over 0. This is bad. So I get 0 over 0, bad. The only thing I have to work with, is this right here. Okay, that's the only thing I have. If I can somehow use this sine junk over junk, if the junk matches, right, then I know that this limit will be 1. The junk has to match and they have to go to 0. So you ready for this? I'm going to kind of, probably if you've never seen this, I'm probably going to blow your mind here a little bit. All right, watch what I do. Limit x goes to 0. So first thing I'm going to do is I'm just going to rewrite everything by kind of like peeling everything apart into different factors. So sine of 5x over sine of 4x is the same as sine of 5x over 1 times 1 over sine of 4x. Got it? Now, critical step. This is the part that's causing the problem, right? Remember we talked about this earlier, like we're trying to always get rid of the thing that's causing the division by 0. So that sine of 4x is the issue, all right? Now, I didn't point this out, didn't stress this. I didn't stress it, I should have. This formula, you see this formula? Gives you 1. What do you think the reciprocal of this would give you then? So like, what if you had junk on top and sine of junk on the bottom? Like, what if those were flipped? What do you think happens to the answer?
5 becomes 0, or no, -1.
It flips. It just flips. Okay. So if you flip this over, put junk on top and sine of junk on the bottom, then your answer flips, and that means 1 turns into 1/1, which is still 1. In other words, this formula can work both ways. The junk can be on top with the sine can be, you know, the sine with the junk on top and junk on the bottom, or you could have junk on top and sine of junk on the bottom. I'll write it down next class, but I only have 2 minutes. So I just want you to get a feel for what I'm about to do, all right? So I'm sitting here and I'm going, shit, sine of 4x is bad. I don't like it, right? I really wish I had what up here?
4x.
4x, right? I really wish I had a 4x up there. I don't. So what I do is I make a 4x appear by multiplying by 4x over 4x. Now this 4x will be able to be slid on top of that. And now I will get 4x over sine of 4x. The junk will match, and this whole thing should go to 1. Do y'all follow me? But now I have a new problem. Do y'all see that I now have a new problem? See that x right there? X is going to go to 0. And I've created a new division by 0 problem. And so I go, shit. You don't have to say shit. Okay. You can get frustrated however you want to get frustrated. But now I have this new issue, right? So I'm sitting there, how am I going to deal with this, right? Watch. I'm going to be so clever here. I'm going to take that x and I'm going to push it under here. Okay. Do y'all see there's an x under here now? But what am I missing? A 5.
It's not, yeah, it's not
Five.
I need a 5. Well, it's okay. I can make a 5 up here. I just do 5 over 5. And I take that 5 and push it under here. I know this is crazy. First time you see this sort of thing. So here's what I'm going to have. I'm going to have sine of 5x over 5x times 4x over sine of 4x. Okay, so what is still over here? I took this 4x and slid it over. I took this x and slid it over. I took that 5 and slid it over. So what's still over here?
The 5.
I have a 5 on top, right? That 5 and that 4 on the bottom. And now let's run the limit.
Wait,
Sine
wouldn't
of
this
junk
be
over
getting
junk.
getting lucky again?
What's that?
Wouldn't this just be like getting lucky again? Like if you know, the very first, like just pull the 5 force out.
Well, wait a minute. Oh,
I know you can't do that. I know you
what you're
can't do
saying.
that.
I know what you're saying. Like, could you just like pull the 5 out and the 4 out and then they cancel? Yeah, on this problem, it looks like we could like do it wrong and get the same answer. They're not all going to be like that though. Yeah. So, all right, this is weird stuff. We need to do more examples of this. I understand the first time you're looking at it, you're like completely lost. That's okay. Don't worry about it. What you need to be able to do is try your homework for 1.4, but only focus your attention on the first 30. No, not 30. Let me look at the assignment. Oh. What the hell am I doing? Okay, schedule. So 1.4, I don't know. I would say try to do up through 28. See if you can get that far. And I will tell you the problems that are the most important. Those right there are the most important problems right there. My recommendation, if I were to be giving you advice, is to do 11 through 28, all of them. Okay, every single one of them. Because the more practice you have, the better off you're going to be. All right. All right, we are out of time. Any questions on what the homework assignment is or anything else? We have
I
a
have a
test.
question.
Yeah, go ahead.
So the problem that we did now, will it be on the test?
Oh, yes. Like this one?
Yeah.
Yes, that will
Okay.
be. And I'll tell you what's going to happen. There are going to be students that get it and they get it perfect. And then basically everyone else will just kind of like wave a white flag because they never figure it out in the homework. They never figure, and so they just say, you know what, I'm just going to have to take a hit there. I hope that doesn't happen, but you will definitely be tested on this because this is an abstract idea. Like this is kind of like, you have to figure out what to put in there, right? Like you have to see it and go, oh, I'm going to insert this out of nowhere. Just pull it out of the air. Just be like, oh, I'm going to put that in there, right? And oh, I need this now. I always think of it like a boat that's sinking. Okay, so like initially the yellow part was the division by 0. So I always think of like a boat that's sinking. There's a hole, right? So you like patch the hole, and then you realize when you do that, there's another hole. So you go and try and patch that hole, and then there's another hole. So you're trying to like patch all the holes and keep it floating. And that's what all this is over here. It's you kind of doing what you need to do to make it work. So, all right, we'll get more practice. Don't freak out. Like if you're looking at that freaking out right now, don't, because we're going to do more next class. But
a quick question.
Yes.
Should just leave it as 5 over 5 or 5x over 5x? Because you did 4x over 4x.
Here.
I'll go up if you don't mind.
Yeah.
Is it just 5 or 4x?
So I did 4x over 4x because I needed a 4x here, right? I was missing both the 4 and an x. So I had to come in with a 4 and an x, right?
Uh-huh.
And when I did that part in green, that x became a new problem for me because it created division by 0, right?
Okay.
Yes.
Would
So
you do
what
5x though? Or just leave it as 5 though?
Well, think about how I did it. I said, okay, well, wait, this x is a problem, but I see this over here and it's begging for a 5x, right? It's like begging for a 5x on the bottom. And I said, shit, I already have an x over here that I have a problem with, right? So why don't I move that x over here? And I no longer have that division by 0, right? Here, but I'm missing the 5.
Okay.
So I only came in with the 5 on top and bottom. I didn't need the x. If I would have done 5x, then I would have introduced another x that would have given me division. Does that make sense?
Yes, sir.
So I only did exactly what I needed to make everything look perfect for the formula.
So for the homework, do you want us to do like what's listed on there, or do you rather want us to do, you say like what, 11 through 28?
What I'm saying on the schedule is that for today, you're not ready for these, okay? These are like the problems that I'm doing right now to end class. You need a little more experience with those before I just send you to go do them, all right? These problems are the most important problems that you can do right now for yourself. And my recommendation is that get through all of these and then go back and just do the ones that I didn't include. Right? Does that make sense? It's like there's no such thing as too much.
Yeah, I get what you're saying now.
Yeah. You will have this as your assignment. This will be part of your assignment. These and these will be assigned to you, just not yet. We're not done with 1.4. All right. Anything else?